Welcome back, Chemistry Theory, to the final part of the video, part 3, with the 16.4 booklet. So we looked at Hess's law of summation. The last part we'll look at kind of a different way of tackling those questions. So reactions which involve compounds formed from their elements are ones that involve enthalpy changes. And this is referred to as enthalpy of formation. And we could have used enthalpy of formation equations here, but for this part, we just simply used equations that we know will result in the final one. So no worries there. I will give you the equation I'm looking for and the equations which you can manipulate. Now, standard enthalpies of formation, I've also given you a sheet that has enthalpy of formation values. And if you look at the top of the sheet, it's from the textbook, and those values are taken from situations that involve one atmosphere of pressure and 25 degrees Celsius. So those are the heats involved when a compound is formed from its elements, for example, water formed from hydrogen and oxygen, during these conditions. Okay, because those enthalpy values change depending upon the atmospheric pressure and also the outside temperature. So energy involved when a compound is formed from its elements, as I mentioned. And if we look at kind of a schematic here, enthalpy of formation graph. Those values, as I mentioned, they're from page 921, but I've photocopied that and given it to you. So first of all, just free elements, they're considered being formed from themselves, so they don't involve an energy value. So free elements such as sulfur and even diatomic ones, nitrogen gas, oxygen gas, are considered to have an enthalpy value of 0. But when they come together to form compounds, energy is released or absorbed. So for example, nitrogen and oxygen combining together to form 1 mole of nitrogen dioxide, it involves the absorption of 33.2 kilojoules for every 1 mole. Or if I look at when oxygen and sulfur combine to make SO3, it involves the release of 454.5 kilojoules. Okay, so key things to note, free elements are 0. Other than that, the compounds do have an energy associated with it when they're formed from their individual elements. So to figure out this, instead of manipulating equations, we'll use those values. And the equation looks something like this. The enthalpy of the reaction is equal to all of the formation values of the products, add them up, which is this Greek symbol sigma here, which means sum up. So add up all the enthalpies of the products, add up all the enthalpies of the reactants, and again we're looking for the difference there. When reactants form products, we'll get the overall heat absorbed or released. And you've seen something similar to that is when we look at the enthalpy here, it's the difference between products and reactants. So enthalpy is equal to products minus reactants. Same thing here, products minus reactants after we've summed them all up. Okay, so going through an example here, we have this one. Sodium bicarbonate, breaking down into sodium carbonate, carbon dioxide gas, and water. So this represents baking soda when it is used in cooking. And what we try to get out of that, of course, is the carbon dioxide gas. And another thing to note is identifying reactants and products. Now you should know by this point that everything on the left-hand side of the arrow is a reactant. Everything on the right-hand side of the on the right-hand side of the arrow is a product. And it's always final minus initial, products minus reactants. So I think sometimes people get confused is that reactants are first, products are second, so it's reactants minus products, but that's not the case. So it doesn't hurt to label it. So here, reactant, sodium bicarbonate, and my products, sodium carbonate, carbon dioxide, and water. Now, if we have more than 1 mole, on page 921 or that handout, those represent values for 1 mole. So if you have more than 1 mole in the question, you're going to have to multiply. Now, the products here, these are all 1 mole, so there's no issue there. But this one, sodium bicarbonate, I have to multiply that number from the back of the book by 2. So if you look at your sheet there, your enthalpy of formation sheet, you'll see that sodium bicarbonate is negative 950.8 kilojoules. doubled it because we have double, negative 1901.6. And then the rest of these are just simply multiplied by 1 mole because I have 1 mole. 1, 1, 1. So the numbers we find in the back of the book are the numbers that we're using there. So sodium carbonate, negative 1130.7. Carbon dioxide gas, negative 393.509. And then be careful here. There's different values for whatever state water is in. We're looking for water in the gas state, so make sure you use the gas state value, negative 241.818. Okay, so now that we have all the enthalpy values of formation of each of those, next comes the application of the formula. So all of the products minus all of the reactants. So all my products include these three, negative 1130.7, negative 393, and negative 241. Subtract all of the reactants, which in this case I just have 1. Okay, so that's what I have so far. So just simply combine all the products. You should get negative 1766.027. All of the reactants, negative 1901.6. And of course here a negative and a negative will lead a positive. So that's going to leave me with plus 135.6. So not too bad. Doing the next one here is the formation of water here. So if we look up the values for these, hydrogen gas, oxygen gas are the reactants. Oh, sorry, it's not water, it's hydrogen peroxide in the liquid state. If you look up that, we'll get the value. Now remember, hydrogen free elements are considered to be 0, or the diatomic elements are 0. They're not on that sheet, and if they are, they have values of 0. Hydrogen peroxide, if you look that up, negative 187.8 kilojoules per mole. Well, I'm having issues here. Let's see. Okay, and then products minus reactants. So there's my one product. There are my reactants. So I have negative 187.8. Subtract a total of 0, so negative 187.8. Which makes sense because really nothing changes here, because this value that I have for this reaction is technically the enthalpy of formation of hydrogen peroxide. Okay, the remaining questions you're going to do, so I'm going to give you the answers. So for this one, the answer should be negative 175.983 kilojoules, so you can get that down. The next ones, D, you should get an answer of negative 1036.036. And E, you should get negative 2435.72. So make sure you run through those, the same method that we did, and hopefully you can get those answers. Final vocabulary here to review Hess's law. If you add equations to result in a final equation, then the enthalpies of those reactions add up to give you the overall enthalpy. So this is just like that value I had earlier, that example. And lastly, standard enthalpy of formation. The enthalpy that results when 1 mole of compound is formed from its elements. So for example, water is formed from hydrogen and oxygen. And if we look at that handout sheet that I gave you, it gives you the value associated with that. Okay, so there you have it. That is the end of booklet 16.4.